Hello and welcome back to the Knowledge Center here at Itron Utility Week. My name is Adam Malik. I'm joined now by Felix Davis, who's the product manager at Cisco. Felix, thanks for making the time to be here.
Thank you for having me.
And we've interviewed a number of people from Cisco, so I'm just setting this up and creating some context for people watching. Okay. And there's been a lot of talk about the evolution of IoT and what's happening in this particular industry, about the need for edge compute and intelligence at the edge. And also a lot of talk about how your routers are becoming much more smart, much more intelligent, much more programmable. You can write apps for them. They're based on an open standard.
Right.
And what would be really great from you as someone who's a product manager on that side of things is just to bring that a little to life a little bit, and tell us a little bit about the use cases that you're seeing in this particular industry.
Okay, absolutely. Yeah. So there's Cisco and Itron have a very strong vision around the potential for distributed intelligence. And you really need to start at what's the drivers. Why would you need more distributed application processing? And there are a couple different factors. One of them is just the fact that this is such large scale. With IoT, you're going such large scale in terms of number of sensors. The amount of data being aggregated is tremendous, and the low bandwidth networks that you're communicating over. So, and there could be more introduced latencies to these communication networks. So there's a lot of reasons why you need application processing towards the edge. And when I say edge, it's a combination of Itron smart meters as well as Cisco field area routers, or even in the substations from a utility perspective. So there are some simple use cases like protocol translation or distributed data processing at the edge, such that you don't have to send all that raw data back to the head end. You could only send report by exception, only send filtered amounts of data back to the head end. But then there's more advanced use cases where you really turn the network into more of a general purpose sensing platform. And so Itron has some really interesting demos here where they show apps running on the meter, the same thing as applications running on the router itself. You can do local control. So for example, you get to more microgrid scenarios. Duke Energy has a really interesting scenario where this coalition, the Willing project, where you have, especially when you have local storage, local distributed generation, and local metering, all communicating amongst themselves to do local control decisions around N-way power flows. And that's kind of where it's going to be very disruptive in terms of how the traditional energy is flowing through the grid, and that you're needing that local control to how, when you store, when you reroute power into local storage, when you consume power from local storage. So local control, Duke has, for example, this field message bus that's be able to communicate amongst different devices. So those could be applications running on the router, running on the meters to have, again, multiple local microgrid scenarios.
So it's becoming really important that the router, the devices that are connected to it are actually connected on a programmatic level, right? Because back in the day, it was always just on a data level. Can you tell us a little bit about the possibilities of where that can take us? And also, one of the issues that I hear a lot within this sector is like, oh, how do we update it? How can we update these applications at scale? Can we make sure that it happens, to that latency piece as well?
Right. So absolutely. So Cisco is working on more of an application hosting platform called IOX, where you allow developers to build apps on our various parts of network infrastructure. It's not just our field area router, but we're embedding that across switching, routing, security appliances pervasive throughout the network. So our focus is on building like Docker containers, containerized applications, and be able to manage those at large scale and securely identify those applications. So we're doing about lifecycle management for the apps themselves. And there's another dynamic too that's much broader across IoT, is around security. So edge security. So because you want to look at what types of data flows are coming through your network and look at anomalies at the network itself. It's a combination of distributed security policies as well as centralized security, especially with IoT. You want to be able to look at the data flows coming through the network and seeing what behavior is anomalous behavior, and be able to do local firewalling or security posturing at the edge.
So is that isolating it locally before anything
exactly.
happens.
Limiting the denial of service zones, kind of having layered security throughout your network, having that visibility, and a lot of that comes with IOX third-party applications running on network infrastructure.
So can I challenge you a little bit, and let's go to other industries.
Yeah,
right?
yeah.
And again, it's one of those things with interviews I've done in the past. People are really worried about, you know, deploying firmware updates at scale and everything. You know, can the data handle it? Which it can, but you know, could you bring some other industry experiences into this conversation just to show what is actually possible when you look at what I call these data networks as intelligent networks, neural networks almost.
Yeah, I think there's some really broad trends across the IoT industry that it plays not just in the utility industry, but across a lot of industrial IoT industries. And some of the big trends are predictive maintenance, asset monitoring. That's a really big one in terms of local decision making and control, but and IoT in general, because these assets are very expensive capex in terms of OpEx as well. So you want to be able to more predictively understand what's the state of that asset. So for example, in mining, you have these massive vehicles that have like hundreds of sensors now on those vehicles. Having them come off of operations is costly, millions of dollars per hour in terms of operational expense. So being able to monitor that and be able to take a vehicle off the line before it fails. And that asset extends to utilities or other transportation systems, trains, vehicles as well, manufacturing plant systems, these big PLCs or other machines. Being able to do more predictive maintenance is a very broad-based and very positive ROI business case for IoT that we see. And in utilities, transformers or other gear, capacity load management and asset monitoring is a huge trend for distributed intelligence.
And do you feel like, and I'm going to use my words, so these are not your words, but I sometimes feel like in certain areas this industry has uniqueness and it has got anomalies, but in a lot of areas also there are a lot of things that can be learned from other industries which are much more advanced. And do you feel that with this more homogenization of the networks, everything being a little bit more IP-centric, a little bit more standardized, that this industry can really benefit from those lessons, like you said, from the mining sector and the asset, in terms of asset management? Are you seeing that?
Yeah, absolutely. There's so many parallel threads, and there's some best practices of how to deploy IoT systems across manufacturing, transportation, oil and gas, smart cities. So there's for example, security. How you deploy enterprise-class security that can scale in terms of device authentication, authorization, encryption, data privacy. There's a lot of parallel best practices that can be learned there. How you build open multi-service networks based on IP, like as you mentioned, so you can re-leverage the common network infrastructure for more use cases. Because, for example, in smart cities and other places, we don't know all of the use cases that are going to become. There's so many new ideas. The technology is innovating so fast. But if you can you can start with a basic architecture that you can give you that future-proofing, that you don't need to rip and replace how you do security, how you do quality service. Those services are embedded in the network to begin with. Those you can apply in smart grid utilities, and the same policies you can apply in oil and gas, manufacturing, and other industries.
And do you think that also the ability to program and deliver applications on the router is a way of that future-proofing? Because I mean, I don't want to belittle it. It's probably way more complicated than this, but it's a bit like an app store, right? Where you've got, hey, let's try this use case, and you can deploy it. I mean, is that really the vision of where we're going?
Yeah, absolutely. So, for example, another one, we have a number of different partners running applications on IOX, what we're calling. So, for example, OSI Soft is putting their Pi software on IOX, so that you can do local data filtering, protocol translation, but also things like SAS or building complex event processing logic. So you can do event stream, again, processing. You can do, as different types of data goes through the network, you can do customized alerting and alarming, for example. SAP has been putting applications on our network infrastructure for crane management, so that the cranes do avoid collision avoidance for cranes. There's so many different types of scenarios there that why you want local decision making and local intelligence for faster, local, lower latencies.
Do you see that the use case of, and we're seeing this a lot more, of microgrids actually really coming to the fore? Because I feel like there is a reticence to deploy this at scale for the entire area, whatever. You know, are microgrids a way to go because it becomes more containerized and it becomes easier to roll out?
In small areas, yes. Yeah, exactly. So in small, either academia or military bases or smaller communities, it is, if it's a small size, it's an easier project to kind of work with the regulators for investment. So large scale is still going to be a challenge. But yeah, microgrids are a little bit easier if you have a self-contained community or environment and a better containerized problem you're trying to solve in terms of load and the number of communities, the number of people kind of in that microgrid scenario. So distributed intelligence and security is fundamental to making that happen.
I think on that note, we'll leave it, because that's given us a great overview about what the product does, and I love the use cases from the other industries that can be applied as well, Felix. So
great,
thank you for joining us today, and thank you as well for watching this interview at the Knowledge Center at Itron Utility Week.